Hey, welcome to iFlip for Math, Mathcast number 4, Volume of Rectangular Pyramids. I'm Mrs. Gooding, and this is a challenge lesson for us. It's not one of our normal learning targets, so it may be a little harder than you're expecting, but just have a lot of fun doing it. By the way, our quote is by Martin Gardner, who said, "All mathematicians share a sense of amazement over the infinite depth and the mysterious beauty and usefulness of mathematics." And he was an amateur mathematician, but he was fabulous at making math really understandable and really, really fun. So if you Google some of his mathematical puzzle books or puzzle activities on the internet, there's lots of great examples, and you can try them out and stretch your brain and exercise those math muscles, and hopefully you'll have some fun doing the volume of rectangular pyramids tonight. Our learning goal is to use the correct volume formula to find the volume of rectangular pyramids. Different solids are going to have different formulas, and finding the volume of rectangular prisms is something we've worked on. So now a pyramid has a different formula, and you'll see what that is in just a minute. Our individual lesson learning goals are to use the volume formula for rectangular pyramids to find the volume. So in this case, one of the commonly used ones is volume equals 1/3 of the base times the height, and I'll show you how to do that. The first step in doing that is going to be to multiply the length and width of the figure to find the base, and we've done that as we're finding the area of the base of other rectangular prisms. So now we're going to multiply the base times the height, and then we're going to divide that amount by 3 to find the volume. And that is the step that is different than just finding the volume of rectangular prisms. It's dividing that total amount by 3. So let's look at the vocabulary. The volume, remember, is the measure of the amount of space inside of a solid figure. We previously looked at rectangular prisms. Now we're looking at pyramids. And the definition of a rectangular pyramid is that all pyramids are named by the shape of their base. So a rectangular pyramid has a rectangular base, or a rectangle for a base, and all of its other faces are triangles. They go up into an apex or a point at the top. We sometimes have called them vertexes in the past, so now you've got a new name for it. Here's our first example, and that's a really cool picture of just kind of some volume work that they used to do. The year was 1916 in a school in Massachusetts, and you can see that volume has not changed much, except it looks like they used to call rectangular prisms rectangular bars. So we're going to use what we learned in that lesson and just stretch it a little bit further. Here's our first example, finding the volume of a rectangular pyramid using the specific volume formula that I told you about. And you can see the figure right there, and I'm kind of going to show you what it looks like when it's drawn too. So let's go ahead and check that out. So you can tell that my sketchbook updated, and I have a new sketchbook pen, and it's really skinny, and I really had to practice a lot to draw with it, but you can still see our rectangular pyramid. Here's the pyramid. It comes to the apex at the top, and here's our rectangle right here. It looks like a parallelogram, but that's just a result of drawing it so that it looks 3D. It's actually a rectangle. If you looked at it, it would just be, if you looked at it, just turn that shape upside down and looked at the base, it would be just a plain rectangle. And if you've forgotten what that looks like, it just means it's going to look like this, coming up into a point right at the top. This is as if we're looking down from the top. So we're going to start with our volume formula. I already wrote it. V equals 1/3 the base times the height. And we talked about how in our rectangular prisms even, that the base is length times width. So we're going to leave this 1/3 right here, and I'm going to put the measurements for the base and the height inside parentheses. So we know that if this is the base, the length is 8 and the width is 7. So we're going to multiply 8 inches times 7 inches. I'm pretty bad at this. Times the height, which is that up and down dotted line, which is 6 inches. I've got a lot of practicing to do on my handwriting. So we begin multiplying those. We'll leave this front the same, just like we would in using any order of operations. We do what's in the parentheses first. So we're going to begin by multiplying 8 times 7, which gives us 56. And because that's the length and the width, which are two dimensions, the dimension of length and the dimension of width, we now have an answer that is squared. And we're multiplying it by our height, which is still 6 inches. 1/3. So now we're going to multiply 56 times 6, and I already did that for us. It's 336. And that is cubic inches, now that we've added the dimension of height and width and length. And now, this looks a little bit unfamiliar to a lot of 5th graders. And you could multiply 1/3 times 336 over 1, but you can also just divide 336 by 3, and that gives us 112. So our final answer is 112 cubic inches, and I'm going to box that because that is our final answer. And we just found the volume of a rectangular pyramid. Let's try another one. So here's our first practice problem. It is another rectangular pyramid, and the dimensions, the length is 6 centimeters, the width is 4 centimeters, and the height is 5 centimeters. So use the volume formula to find the volume of this rectangular pyramid. Go ahead and look at the notes that you took from the example into your flip journal and figure out that volume, and then push play when you've figured it out and you've written it down. Did you write 40 cubic centimeters? Let's see how we did that. So if you can tell, I'm using the same rectangular pyramid. I'm kind of afraid to delete it because the other ones that I drew were way worse than that one. But you might have some fun trying to draw them and see if you can make yours look a lot better than mine. It's always a little bit challenging to do them on the bamboo tablet. So we've got our volume formula, 1/3 the base times the height, and we are going to plug in our numbers. So the 1/3 stays the same. The base is going to be our length of 6 centimeters times our width of 4 centimeters, and then our height is going to be 5 centimeters. So I'll rewrite it. This is such great practice for when you're doing algebra stuff. Well, volume too, but algebra. So now we're going to multiply the first set. 6 centimeters times 4 centimeters is 24 centimeters squared, because we have the dimension of length and width. And now we're going to multiply it by the dimension of height. And 24 times 5 is 120, I think. Yep, 120. 120. And with that third dimension added in, we now have 120 cubic centimeters. And in order to solve this, we're going to take this amount and divide it by 3. So we could do mental math. We know that 12 divided by 3 is 4, and we have a 0 left over. So our answer is 40 cubic centimeters. Woohoo! Oh, that box is almost worse than my pyramid. There you go. We solved for another pyramid. Let's try another one. Okay, practice problem number 2. You can see that this rectangular pyramid has a length of 4 centimeters, a width of 10 centimeters, and a height of 6 centimeters. And every picture that you see is going to look just a little bit different, and that's okay because you may see them written differently in textbooks or in worksheets or wherever you happen to be using them. Use the volume formula to find the volume of the rectangular pyramid. When you've figured it out, push play. Did you write 80 cubic centimeters? Let's see how we did that. Okay, so I have my pyramid with a length of 4 centimeters, a width of 10 centimeters, and a height of 6 centimeters. And I've written my volume formula here. Volume equals 1/3 the base times the height. So volume equals 1/3. We're going to find for the base first. It is, the length is 4 centimeters, and the width is 10 centimeters, and our height is 6 centimeters. So we're going to do the base first. 4 times 10 is 40 square centimeters times my height. And I could do those all at once, but I am separating out the steps because I want you to see exactly what's happening every time I write a new number down. 1/3. And I'm going to use my mental math to multiply 40 and 6. 4 times 6 is 24. And add my 0. And now, because I have 2 dimensions here and 1 dimension here, I have cubic centimeters, or centimeters to the 3rd. You can see that. To figure that out, I just divide 240 by 3. 3 goes into 24 8 times, and I have a 0 left over, so I keep it up there. So 80 cubic centimeters is my answer. My writing is getting better, but my boxes and my pyramids are not. It's time to challenge yourself. So there's our figure. Look at that. It has extra numbers on it. It has decimals. It has big numbers. This should be a great challenge problem for you. And I want you to use the volume formula to find the volume of the rectangular pyramid. I'm going to go ahead and solve this with you tonight. So you find it, pause your computer, and then push play when you're ready. Did you write 4,480 cubic feet? Let's see how we did that one. So since I told you to challenge yourself, I decided to challenge myself too, and I actually redrew that rectangular pyramid. It's not really better. It just looks a little bit more like the figure that you saw in the keynote. So I have some unimportant information in this. I can call this my length and this my width, or this my length and this my width. It doesn't matter. But it does matter that I call this dashed line my height. This number over here is not part of the length, the width, or the height. It's another measure on that figure, and we don't need it. So we're going to ignore it and solve for our formula. 1/3, and our base will be our length, 32 feet, times our width of 17 5/10. Oh, that doesn't look like 5/10 feet, and our height of 24 feet. Volume equals still 1/3. And 32 times 17 5/10 is 560 square feet. It's important that I keep my dimensions correct as I work through my problem. It just really ensures that I have a better understanding of what I'm doing. Times my height of 24 feet. So 560 times 24 is actually, and I hope you worked out the multiplication, 13,440. I try to work these out ahead of time so you don't have to watch me fumble through them on the bamboo tablet. I have to practice. Cubic feet. And to figure out the answer to that, and I'm going to work out the division problem here, because this point in the year I've noticed some of you are struggling a little bit with your division, so I want to make sure we review it. So 3 goes into 13 4 times. 3 times 4 is 12. 13 minus 12 is 1. Bring down the 4. 3 goes into 14 4 times. 3 times 4 is still 12. 14 minus 12 is 2. Bring down the next 4. 3 goes into 24 8 times. 3 times 8 is 24. I do need to stick with these 2's. I'm better at them. 24 minus 24 is 0. And I'm not finished because I have to have a roof over every room in my house, and I don't have a roof here. So I'm going to bring down that last 0. Go through my steps one more time. 3 goes into 0. 0 times. And I now have a complete division problem. And I also have an answer of 4,480 cubic feet. Hopefully you had a lot of fun with that one. It was a good challenge one. Let's go ahead, and I have one more challenge for you tonight that I think you'll really like. So I wanted to give you just a little example of one of Martin Gardner's challenge problems. So this is your second challenge problem of the lesson. Martin Gardner had a puzzle called the two spirals. One of the spirals, I'll show them to you, is formed with a single piece of rope that has its ends joined together. The other spiral is formed with two separate pieces of rope. They each have their ends joined together, not joined to each other, but joined to itself. Can you tell just by looking at it with your eyes, without touching it with your fingers or your pencil or anything, can you tell which is which by using just your eyes, as I said? So, which one is the single piece of rope and which one is the double piece of rope? And make your prediction and then push play when you've figured it out. Did you pick that second one as your double rope? You can kind of see it. They've drawn it out in red and green so that it's really easy to tell. Hope you had kind of fun doing that little challenge, and remember, you can always Google him on the internet and find a lot of other really cool brain teasers type puzzles. Finishing up, there's a picture of him doing a card trick, kind of his Hocus Pocus book. Do you need to go back and review any of these problems? Do you want to Google some other rectangular pyramids and figure out their volume? You can always use that formula with any rectangular pyramid, and you can always practice on your own and then just kind of check your multiplication really carefully. I hope you really enjoyed Martin's marvelous mathematical puzzles, and congratulations. You've completed Mathcast number 4, Volume of Rectangular Pyramids. I can't wait to see you tomorrow.